Overhead garage door openers are very common in the modern world as they provide a safe and easy method of opening your overhead door without causing injury or back strain. They usually have a half horsepower motor and operate using two methods of control, one being a wireless remote and the second being a mounted control panel for the motor. The issue becomes, however, if you don't have a remote for every vehicle you own, how do you decide what vehicle gets the controller? Companies in recent years have developed solutions to this, such as Chamberlain, who now started producing a Wi-Fi and smartphone controlled Bluetooth or Wi-Fi garage door opener. However, this unit is fairly expensive, and if you already have a half horsepower motor, there's an easier solution that won't cost you nearly as much. My name is Ethan, and I present to you the Bluetooth garage door interface. The objective of this design is to provide in-pocket control using any Android device, and via Bluetooth communication actuate a garage door opener using Arduino controls. This design integrates into any pre-existing half horsepower door controller, operates through a 5-volt phone charger, operates on any Android OS device, has a small packaging but will operate in most temperature ranges, and utilizes the same pre-existing controls as your garage door opener comes with. But most importantly of all, this product will only cost around $40 instead of the $342 that Chamberlain charges for their Wi-Fi controlled system. This block diagram demonstrates how the system works. We have our 5-volt power supply coming from our phone charger in the wall, which connects directly to our Arduino controller. Then that communicates through the Bluetooth module through a logic level converter, just so we ensure that none of our components get damaged. The Bluetooth wirelessly communicates back and forth with any Android device using the pre-made app, and we send those signals to the Arduino, which then signals the relay switch to flip the motor. This design uses any ATmega 320AP microcontroller development board, so you can use a Nano or an Uno. You can even use a 2560 if you have one available, but if not, it will work just fine with any ATmega 320AP. We're using a 5 volts to 3.3 volt logic level shifter, a 5 volt relay module, and a HC05 Bluetooth module as well. Taking a look at the system specifications, we see that the input voltages are all 5 volts except for the relay module, whose common terminal gets a 16.5 volts source, which comes from the half horsepower motor controller itself. The outputs are, again, 5 volts, 5 volts, 3 volts for the logic level converter, and the relay module outputs that 16.5 volts through the normally open contact, It has a low power consumption of only 10 watts, and the indicators on the HC05 and relay module show us when we're scanning versus connected, and then depending on which, for the relay module, it shows us which contact is engaged. Since this is just a retrofitted product on a pre-existing controller, we retain all features of the original controller. My design incorporates the trip sensor that my door came with. So it's an infrared sensor which stops the door from closing if anything is in its path and automatically reopens it. This ensures that if a child or animal happens to be underneath the door while it's closing, they won't get injured. We're also using a 4-byte custom passcode encryption through the app interface, and that same app auto disconnects the Bluetooth client once it is closed. It's a small dimensions of 85 by 110 by 48 millimeters for the enclosure, and it comes to a total weight of 161.7 grams, so very easily mounted to your wall. It can operate in temperatures from negative 20 degrees Celsius for 75 to 75 degrees Celsius, which ensures that it will function in most climates. I live in maritime Canada, and it has been operating all winter just fine. the range of the Bluetooth, it can connect at 25 feet and be controllable for up to 45 feet. This may be less than the range of operation for the controls that come with the garage door opener. However, the ability to have the control in pocket at all times greatly outweighs the extended range that the controllers have. For control, we have two starting states, open and close. If we press the button once, it'll begin to close. Press it a second time, it'll open. And if we press it a third time, it'll pause. If we start off close, we will open with one push, close with a second push, and pause with a third push. And after control, it defaults to 1. So if it's paused and we hit it again, it'll go back to close and open. So that concludes the system specifications. So let's go outside and I'll give you a demonstration of how it actually operates.
Alright, so first thing you're going to want to do is open the app that you made using MIT App Inventor 2 and connect receiver. And once it's connected, you can hit open and close to operate the door. So as you've seen, hitting it once will open or close it depending on its original state. Hitting it a second time will change the direction of motion, and hitting it a third time will just pause it where it is. Alright, so a bit hard to see with the sun, but this is about 20 feet away and it will still connect. So it's connected, and as we carry back, and now from about 30 feet away, it still triggers the door. This circuit uses an HC05 Bluetooth module, a 5 volt to 3.3 volt logic level converter, and it's powered using an Arduino INO. This terminal block connects to a relay, which is what's actually triggering the door's motion. And on the actual design of the shield, here we have the receive pin of the HC05, which connects through the logic level converter to the transceive of the Arduino. This ensures that we don't damage this component by transmitting a voltage that's too high, because it can only receive a 3.3 volt but can transmit a 5 volt from the Arduino. Next, the transceive pin connects directly to the receive pin of the Arduino, and it gets ground and a 5 volt power source. That same 5 volt power source goes to the common terminal of the relay. The ground goes to this side of the relay, and this is the signal pin for the relay, which correspond to the terminal blocks, which powers the door opener. This entire design is soldered to a proto board shield, which connects directly back onto the Arduino. It fits nicely in this little plastic container I got from the dollar store, so that it has a bit of weatherproof, but also makes it look a bit more nice on the wall and is a bit more quickly accessible. The circuit is powered using a simple cell phone charger plugged into the wall and a 12-foot extension cable for USB, so that I can still use the USB Type B cable that came with my Arduino board. So as you can see, the cable runs all the way along the roof, meets up here, and plugs into the wall here. So that, as mentioned, just uses the existing USB Type B, plugs in, and we can confirm we have power because the Bluetooth module is blinking. So to give you an idea of how the circuit is connected, I've taken off the main control panel off of the wall, and this is the positive and negative terminal from the actual voltage source. This is connected to the actual garage door opener motor, and the red connects to the common of the relay, and the white, which is the ground, connects to the normally open contact. So that way when I send a short signal, it shorts the contacts, and all this mechanism needs is a short pulse to actuate the door controls. So these are 9 volts, but since we're using a relay, we don't run the risk of damaging our board at all, because we're only using it through the relay, which can take up to a 250 volt 10 amp signal. Once again, to demonstrate how the door operates using the regular controller versus the Arduino, this button sends a short pulse to the motor. Since the door is closed, it'll open. If I press it a second time, it'll pause. And if I press it a third time, it'll start to close. Similar to how it works with the Arduino. So, opening, paused, closing. It's also worth mentioning that since this is going through the original manufacturer controller for the garage door opener, I can still use the included safety sensors, which don't allow the door to close if something is in the path of the door. So to demonstrate that, so if I have the door open and I close it, I'll put my foot in the path of the door, it reopens.
So as we can see from the demonstration section of this video, our system functions according to the system specifications discussed in the beginning of the video. We have a range of 25 feet for the connectivity and up to 45 feet for the controllability. In the video we only displayed a 30 foot, but that's because I actually don't have the necessity to have a 45 feet distance away from it, because my driveway only goes out to about 35 feet. But it has been tested and it does work for 45 feet. It's operated in my garage for about 4 weeks, and that is including negative 15 degree temperatures up to 10 degree temperatures. I can post another update video during the summer to show that it works in summer temperatures too. But based on the system specifications, it will work just fine for any temperature range of negative 20 to 75 degrees Celsius, which encompasses pretty much all of Canada and all of the states as well. Overall, it's a very efficient and cost-effective solution versus buying a new product altogether, because this one just retrofits onto any pre-existing half horsepower controller. Any controller that has the same sort of logic as the one demonstrated in the video. That is, when the two contacts are shorted, we get a signal sent to the motor to open or close it. It's been tried on the half horsepower motor that I own, as well as 2 others from friends and family. So it operates on various systems, not just the specific one that I have. But try at your own discretion, and if you want a full tutorial of how to make it, you can check out the other videos on my YouTube channel. But other than that, I hope you enjoyed. Thank you.